Hello, this is the January Approachable Sudoku for the 10th of February 2024. It is Pepper Lines by Philip Newman, and it is a zipper ratio pairs Sudoku. So let's look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Ratio pairs. Digits in cell separated by a black dot must have the ratio given. So those two digits have to have the ratio 1 to 2. Those digits also 1 to 2. Those digits have the ratio 1 to 3. Those digits have the ratio 1 to 6. Zipper lines. For each line, the digits in each pair of the cell equal in for each line, the digits in each pair of cells an equal distance away from the central cell. So for example, this zipper line here, the central cell is that one. For any pair of cells an equal distance away, for example those digits equal distance away have to sum to the central digit. For example, row 1 column 3 is equal to row 1 column 1 plus row 1 column 5, which is equal to row 1 column 2 plus row 1 column 4. So those are how zipper lines work. Right, cool. With that, I guess the rules are done. Let us get started. All of these have to be 1 plus the respective number because no other digits would fit. They would have to be 1/8. No other two digits have the 1/8 ratio. Those have to be 1/7. Those have to be 1/6, and those have to be 1/5. Which does tell us something even more. The middle digit in each of those zipper lines can never be the 1 because you can't have two outer digits add up to 1, and therefore the middle digit cannot be 1. The digit that is not in the middle is therefore the 1, and we can place in the rest of the digits like so. Now with the 1 here, we can definitely just place down all the digits on the opposite side of the zipper line because those two must add up to the middle digit. And also 6 and 5 are very important because 5 only has one other way of making two digits sum to it, which have to be 2 and 3 because it can't be 1 and 4. 6 only has one other way, which has to be 2 and 4. This 2-4 pair looks at that cell, so that cell cannot be 2. That's 3. That's 2. Oh, 3 in the corner. So early into the solve. Wow. Right. This digit now must be a 6. And the reason why is because it must be less than 8 to sum to 8. But it can't be 1, 2, 3, 4, 5, or 7. So this cell must be 6, which must be accompanied by 2. This digit is less than 7. It can't be 1, 6, so it's therefore 2, 5, or 3, 4. It could be either though. This can't be 2, so that definitely can't be 5. But again, it could be either. So that's actually one that is not very disambiguated. This 8 here can't be any of those cells, so 8 must be here in this column. 7, 9 remains in the column which can be disambiguated by this 7 over here. Alright. The rest of the ratio dots are actually very... well, they're not as certain as the ones on the outside. Like the 4 here could even be 2, 8. Oh yeah, it can't be 1, 4 because there can't be a 1 along here, so it must be 2, 8. And we can resolve that in two different ways. Firstly, the 8 here resolves that, but also this digit must be greater than that. So it must be 8, 2 here. That must therefore be 6. Those digits have a regular 1 to 2 ratio. Right, well, we'll come back to that later, I think. This can't be 2, so that can't be 5. Therefore, this forms a 3-4 pair. This can't be 4. That's 2. That's 4. Cool. Actually, maybe let's look at those digits. Those digits have a 1 to 2 ratio. The only way to do that in a 9x9 would be 1, 2, 2, 4, 4, 8, and 3, 6. We can see here from the 6 and the 1, not 2, 6, 3, 6. We can see from the 6 and the 1 that both of these options are removed. Therefore, we have 2, 8, 2, 4, and 4, 8 here. If it was 2, 4, it would have to be 4 here and 2 here because of the 2 up there. If it was an 8, it would have to be 8 here and 4 here because of the 8 here. So that gives us our options for this line. Yes. And we do know 4 is in one of those cells. 9. Right, where does 9 go in this row then? 9 can't be in any of those cells. 9 can't be there either, because this cell is the sum of those two cells, and therefore has to be greater than both of these. This therefore can't be 9, because there's nothing greater than 9. 9 has to go there. Those digits therefore do contain a 3 and a 5, right? Because 3 and a 5 aren't anywhere else in the row. And if it contains 3 and a 5, it must also contain, or it either contains an 8 in the middle, which isn't possible, or it contains a 2 on the side, where 5 is in the middle. Therefore, this 2-3 pair removes 2 from those cells. There has to be a 4-8, which is done like that. 4 resolves this 3-4. Oh, a second 3 in the corner. How lovely. Here we have 5, 7, and 9. This can't be 9 or 5. Wait, sorry. 4, 5, and 9. 4 can't be in those cells, so 4 goes there. I guess this 5 and 9 also say that that's a 4. This is a 5-9 pair, giving us our last digit here to be a 2. 2 here must be next to 1 or 4. It can't be next to 4, so it would have to be next to 1. 3 would have to be next to 6 to form a 1-to-2 ratio. These digits are 2, 3, and 4. Those can't be 2, so 2 actually goes there. 3 goes there. That must be 6. Those digits are 3 and 4. Those digits are 1 and 5, which we can resolve. Those digits have to be 5, 8, 9, I believe. Yeah. But we can't do much with that. This can't be 5, but that's really just it. Alright, interesting. Those digits have a ratio 1 to 3. They can't have 1 or 2 in it. So I'm inclined to say that's a 3-9 pair. Can I prove that? Because how many ways I have to make a 1-3? You could either make 1 with 3, you could make 2 with 6, you could make 3 with 9, but you can't make 4 with anything, because 4 have to be with 12. Yeah, so it has to be either 1, 3, 2, 6 or 3, 9, but it can't be 1, 3 or 2, 6, so it has to be 3, 9, which we can resolve by that 3 over there. This 3 actually resolves this 3, 4 pair as well. 3, 9 pair on the zipper line means that has to be 6. This can't be 9, so that's 8. 6 here, it's a very similar idea to that. This 1, 6 pair, looking at that 2 here means this is either, well, this must contain a 4, right? It's either 2, 4 or 4, 8. 4 sees that cell, so 4 must be there. This has to be 2 or 8. We are now missing, we're missing a 9, 7, 5. We're missing a 3. We're missing a lot of things. Alright, maybe not there then. Let's look at the rest of the stuff here. Like that, maybe that has to be 5, 7, and 9. Oh, but this can't be 5, and in fact those digits we can also place. Those are 2, 7, and 9. This can't be 2, so 2 goes there. That digit is now an 8 to complete the row, which means that is a 2. 8 is already there in the box. Wait, am I stupid? Yes, I am. This is not 5, 7, 9. This is 5, 7, 8. And 8 can't be any of those cells, so 8 must be there. 2 must be there. This must be a 7. Jeez, that is a 9. What am I doing? What am I doing? Those digits are 1, 3, 1, 6, 9. I can't read today. This can't be 6. Okay. Well, let's think about where no, things go anywhere. I'm saying 8 can't be in those cells, but it could be in one of those cells. Yeah, not very helpful. Maybe we look at this zipper line, or here actually. Yeah, this could be better. Because we also, yeah, it can't be 1, 3 or 3, 9, so it has to be 2, 6, which can be resolved. 6 here, 2 there means there has to be 8. Right, therefore now we have 3, 5. 5 is missing. 5 has to be one of those cells. 5, 3, 7, and 9. How would that work? Right, 2. The 2. This is 5, 3, 5, 7, or 9. This can't be as low as 3, but that can't be as high as 9. This can't be 5 or 9, so that's 3 or 7. In fact, this forms a 1, 3, 7 triple. That can't be 3 or 7, so that's 1. 3, 7 here. We could probably fill all of these in. Like those are 2, 4, and 5. This can't be 2 or 4, that's 5. This can't be 2, so that's 4, that's 2. Those digits are 1, 6, and 8. This can't be 6, so that's 1. Those digits are 3, 7, 9. This can't be 3, but I guess more importantly, this can't be 9. This has to be 8, right? It can't be 6 because this can't be 1, so it has to be 8 with a 3 there. So that forms a 7, 9 pair. This has to be 6, which removes 6 from here. 5 resolves this 7, 5 pair. 6 must therefore be here in this area. Those digits are 1 and 9. 1 and 9, which removes 9 from that cell, so that's 5. That's 9. Oh, actually this 1 resolves this as well, so we could probably have done that. 9 here means that's 7, that's 9. That digit has to be 3. Those digits are 7, 8, which we can resolve. 7, 8. This can't be 7, so that can't be 9. Another chocolate teapot. Actually, we could have removed 9 from that. Okay. We're almost done. Those digits have to be 3, 4, and 7. This can't be 3 or 4, so that's 7, which resolves this entire thing. That's 4. 5 resolves this 5, 9 pair, which resolves this 1, 9 pair. 1, 9. This must be 7, so that is 3. Solving the puzzle in 10 minutes and 20 seconds. Well, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.